Good morning.
Welcome. I think I'm going to give everybody just a minute to kind of see if we have any last minute joiners. So we'll just wait around for just a minute.
Sure. How's the weather out there?
Here in Michigan, it's a little cloudy today, but it's not bad.
A little cooler. We actually slept with the windows open. It was first time in quite a while. So,
Great.
How about Florida?
Well, we've got the biggest surf of the year so far from the hurricane offshore. So that's the big news.
All right. Is the hurricane north of you now?
It is north of us, yes, and pretty far out. But and we were getting some rain, but nothing, no big storm.
All right, guys, should we get started?
I think we should.
It's a minute after. Okay, perfect. Well, welcome everybody. Welcome to our webinar today, Standard and Custom Solutions, When to Consider Designed Rotary Actuators. We are super excited to discuss rotary actuators with you all today, and specifically when standard solutions aren't enough, and when a custom solution is the right answer. I am Sonia Buzak. I'm the marketing specialist here at Donald Engineering, and I'll be your host today. With me, we've got Norman Lane from Rotomation and Jim Kortman from Donald Engineering. Here is a look at what our agenda will look like for today. And how today will flow. If at any point you have any questions at all throughout the webinar, feel free to drop them in the chat as we plan on having a Q&A towards the end. And to start things off, or actually let me introduce Norman. Norman, he is the president of Rotomation. He's been helping engineers tackle rotary motion challenges for many years. And Rotomation's been around since 1967, delivering high-performance, durable pneumatic rotary actuators for just about every industry you can name. And also Jim Kortman, he is the Vice President Technical Sales at Donald Engineering. He's got 30 years of experience and multiple certifications in safety and fluid power, and also a passion for building smart solutions. Jim brings a wealth of knowledge with all of us. And then I think we're going to kick things off to give us a little introduction of Rotomation and their approach to innovation. So Norman, the floor is yours.
All right, thanks. I really appreciate you all putting this thing on. I'm Norman Lane. I'm a mechanical engineer. I've been with Rotomation since 1988. Before that, I was in R&D, machine design work, up north, doing all kinds of different things. So I've kind of been on both sides of the desk here. Rotomation is a small company. You can see our group photo there. We have a machine shop where we make all our parts from bar stock, put them in stock, and then assemble them to order. All of our products are extremely configurable, so that you can get exactly the kind of layout that you want. Beyond configurable, we make specials, and we're going to talk about that a lot today. But we've been into all kinds of business, just about any kind of field in manufacturing in the country. Semiconductor is one of our biggest ones, pharma, any kind of packaging or assembly that needs some rotary motion. All of our products are rack and pinion based. So they all have rotary motion, but then we go into some variations on all that. So today we're going to talk more about configuration, custom, and special. So I'll let Jim take it from there.
Good morning. I'm Jim Kortman, and I do serve as the Vice President of Sales and Things Technical here at Donald. Donald Engineering's been around since 1963, and we are a fluid power distributor, but different than a lot of distributors, we work at being very engineering intensive and try to bring technology and value add application assistance into into the conversation and what we do. We've been around since 1963. We've been in relationship with Rotomation since, I believe, 1973. So a little over 50 years. We've been doing business together. Our focus has historically been, Donald's focus has historically been in the hot, heavy, and dirty industries, and stamping, forestry, forging, oil field, that type of thing. And as a lot of that heavy business left the state of Michigan, we had to reorganize ourselves and figure out how we were going to move forward and what we were going to do. So we continued our engineering intensive thought process, and we went into a lot of things that were short run projects or very hard to do projects. And that led us into a lot of high-end automation. And so besides the traditional fluid power, hydraulic, pneumatic, vacuum world, we also do a lot of servo work, a lot of closed loop hydraulic and other things that way. Also do a bit of controls. Our business takes us into the marine world, into the medical world, a lot of robot end of arm tool, and a lot of dedicated automation. And so that's a little bit about who I am and who we are as a company. And we serve predominantly in the state of Michigan and northern Indiana. And we look to bring high-end engineering intensive solutions to the field and partner with those who are looking for that kind of help. And I think we lost Sonia somehow. So we'll continue on here.
Nope, I'm still
she's
here.
still back.
Yeah,
All right.
I'm still here.
Thank you.
Mhm.
We have a bit of a collaborative process. And so when we go forward and we try to identify what it is we're going to do in a rotary motion, there's some details that we need to nail down. The torque required, the speed required, what special materials we have to have, what's the longevity? How long is this expected to last? Is this a 30-year run? Is this a 3-year run? Those are things that are helpful in helping us understand where we're going to go with this. And also into the conversation, especially in OEM scenarios, there's quite a bit of, can be quite a bit of conversation as to what price point do we have to get to, or where does this need to fit in the overall, whatever this machine's trying to accomplish. So those are some of the things that we're looking to nail down. And Norman, is there any interchange, or are all rotary actuators pretty much special?
There's very little interchange. It's not like an NFPA cylinder where you can pick a cylinder from almost any manufacturer and drop it into the same place. All of us in the rotary world tend to make it up on our own. There is some interchange in a certain number of the rotary actuators, but we're in general not compatible with those. So we can match in terms of torque and maybe shaft size and things like that. But as far as a drop-in replacement with them same mounting holes and dimensions, there really is no standardization.
Okay. As we're looking to optimize, what's the number one thing that we need to really think about when we're trying to optimize a solution, or what are we trying to nail down as the most, maybe the most important detail that we're trying to get to?
Well, many applications have to do with moving a part or a tool or something from one place to another. And very often it's strictly a matter of inertia. You don't have a lot of friction or drag, or you're not necessarily lifting it up. So starting out with the inertia of the load is our starting point. People will think, well, it's just a light little weight, I can push it with my finger. And that may be true, but it doesn't mean that you can control the thing precisely and safely with a very small rotary actuator. It very often turns out to be something that a larger displacement will allow you the control that you need in order to get a controlled motion.
When we start thinking about customization, and we've done a few customization details in the past, and we'll get to some of those, but when we think about customization, what are you most looking for in that customized? Because configurable, you have quite a few options.
Yes, we do. We give the user the choice to almost every parameter of the actuator. I had figured we have about 150 billion standard configurations that you can order and that we can normally deliver within a few days. Depending on our backlog, it might be a few weeks. But so we try to accommodate the customers as much as possible just through our configurability. Beyond that, we start looking at things that will optimize their machine. And probably the most common customization is a shaft. So when I say customization, I mean it's the product is 90% what we call standard. But then we can modify a few parts or even with just one part to make it, to optimize their solution. So very often it's the shaft. They want it longer, larger diameter, shorter, some holes in it, who knows what. So we stock blanks for most of our products where we can take it off the shelf. It's extra long, extra large diameter in both directions. So we can just take their drawings or design as they need and put it in the lathe and put whatever features they need into it without affecting the lead time very much.
That's cool. This slide here up on the screen shows us quite a bit of variety in the stuff that you make. The compact rotary actuators up through the other things. Most of the time when we think of a rotary actuator, we think of a back and forth, going one direction, going the other, 180 degrees, a windshield wiper. Be a good example, but tell us a little bit about some of the other standard offerings and some of the other solutions you've developed.
Sure. So our rotary actuators, as you mentioned, the windshield wiper type of motion, the compact is one series of them, but then they also get larger with tie rods. And then we go into multi-motion actuators. Actually, I'm going to step back on those rotary actuators. One of the things we can do is go up to very long rotations, which is a limitation in many other types of actuators and also some other suppliers. But we can go up to over 1,000 degrees of rotation and still maintain the same kind of accuracy and ruggedness. If you need multiple positions, and this is often used for things like positioning a part for assembly or welding or testing or whatever, we can have 3 positions, 4 positions, or even 5 positions within a rotary actuator. So this is something that has a limited rotation. It's always going to come back. It doesn't keep going in the forward direction. And any of our dual rack actuators can be configured in a multi-position configuration. Then we get into indexing actuators, which is a product which is unique to Rotomation. It's based on a rotary actuator where they share some parts, but it has a ratchet and pawl mechanism and some one-way clutches that allows it to provide an indexing motion. So equal steps in most cases in one direction forever, always going in one direction without any accumulating error. So it's really good for things like star wheels, index tables, indexing conveyors, things like that. And yeah, you can do that with a stepping motor or a servo motor or a cam drive, but those are all much more expensive and complex solutions to a simple indexing problem. We make these everywhere from a small thing you can hold in your palm of your hand up to a large bore, 1 or 2 inch bore, 1 inch shaft diameter. Kind of a side thing to that is the stepping actuators, which has also steps in one direction, but it doesn't have the ratchet and pawl mechanism. So there are no hard stops. It's used for things where you don't have to index and stop. It just, you need to push something forward in certain increments. There are other companies that build things like this. They don't call it a stepping actuator. They call it a one-way clutch option. The difference between ours and theirs is that ours, it's all integrated into the basic actuator instead of just an add-on piece. So we have very rugged clutches, and it doesn't change. I mean, the bearings, the original shaft bearings are still really robust, and they're all integrated into the package. Then we get into multi-motion actuators where we add a linear cylinder to the rotary. And we can do this with any of the rotaries. It can be a 2-position rotary, 3 or 4-position rotary. It can be an indexing actuator. I think we've even done it with a stepping actuator. So it gives you a linear motion. The rod extends and retracts and also rotates. So you'll need 2 sets of valves. They're completely independent of one another. The nitpicker is really just the multi-motion with the indexing actuator as its rotary portion.
So the
So
multi-motion,
that's kind of our rundown.
so the multi-motion is actually the rotary actuator, but if you were to lay it on its back, then the linear becomes a Z, and the Z goes up and down, and
Yep.
the rotary gives you a rotation turn. Okay. Everything you've mentioned is rack and pinion based, and I think this is probably a good chance or opportunity to go to the next slide and talk about that. There are some different technologies, and in the upper left or the left view is a rack and pinion, and what are some of the details in there that we're really looking into? I think we've talked about it's all about the gear and how the gear is cut and the rack is cut to mesh with it.
That's right. Rack and pinion actuators. Actually, this one has the pistons incorporated with the rack. Ours are floating, which is a more robust solution, but they're very configurable. The end caps can be different from one side to the other, so you can have all kinds of different options. They're very rugged. You can have any sort of rotation that you want just by changing the length of the cylinders in the rack. So it's very, very configurable. Now, as Jim mentioned, the gear is the focal point of a rack and pinion actuator. Back in the day when we first started, we were buying commercial gears and attaching them to a piece of shaft and using keys and pins. And that was the biggest failure point that we had. So quite a number of years ago, we went to one-piece pinion shafts that we turn out of a solid chunk of heat-treated 4150 steel. It's not the strongest steel in the world. It's not the hardest, but it's probably about the toughest, which means that when you get to the end of the stroke on a rotary actuator, and you got a big load spinning around, you got a lot of inertia, all of that kinetic energy ends up going into the gear tooth. And so if it's not a really strong gear tooth with a matching really strong rack tooth, something breaks. And when things break, customers are in trouble. You know, if you've got a production line running and all of a sudden your rotary actuator breaks, everything stops. So that's why we have gone to try to eliminate as many failure points as possible. And that was the biggest one.
The next actuator that's on there is a vane type actuator. This is an end view. So you're looking at the end of the shaft, and if air is introduced in P1, the upper left port, then this shaft is going to rotate clockwise. If air is introduced in P2, it's going to rotate counterclockwise. There is a vane seal out on the end. Sometimes that vane seal is problematic because when you get to the end cap, then that seal ends up with a square corner. And so sometimes this is a great actuator because it has no backlash potential, but it also sometimes can be problematic. It's limited to about 300 degrees of stroke, depending on how thick that stationary barrier has to be. So it's a great application, great actuator in the proper application, but it's got some limitations in it and some things that don't wear compensate quite as well. And we have some experience in the helical gear actuator, and we use these in the hydraulic world for massive, massive amounts of torque in a hydraulic application. And a lot of times we see these in cranes, and we see these like in grapple hooks on the end of logging equipment. And so it is a compact, super high torque. And normally we see them in hydraulic. Norman, have you ever seen a pneumatic helical gear, or have they all been hydraulic?
No, I never have. We started to actually kind of develop one, but never went all the way through with it. I think it is a possible solution for pneumatic, but no, you're right. They're all hydraulic. I see them on the back of a garbage truck or something like that. You know, they take a lot of abuse and keep going.
Yep. So kind of a different world, and typically not found in high-speed automation applications or that kind of thing. So yeah, you said you got billion. I thought you said, Norman, about combinations. How do we get there? How does that look?
Well, this is a little screenshot of one of our, I call it a paper configurator. It's you can go in and pick all your optional features. So you can see that we have this very long part number, and each field of that part number, you have several choices in almost all cases. So you start adding up all those configurations, and that's where you get to the billions. And this is just for one series of our actuator. I think that's a 1-inch bore tie rod actuator that we have that page for. We also have a similar configurator online that's interactive, and it enforces the rules for creating a part number and also delivers a CAD model in your choice. It can be a solid model, it could be a drawing, could even be just a PDF. But so this is one of the things that sets Rotomation apart, is that we really let you configure the product to suit your application best.
When we get into this, I think the whole point of this is identifying how customs come to be. And so we've got lots of options here available, but inertia we talked about as being the custom driver, potentially. Shaft ends being the custom driver, potentially. I think next we've got some examples, and like to show a couple of those and go into what we've done and developed along the way to get somewhere. This was a Donald Engineering solution. This solution happened many, many years ago. This is one of our first early specials that we did, collaborated on together. And I have to admit, Norman, this was before my time. And so can you tell us a little bit more about this one?
Yes, I can tell you. In fact, it was early in my career here also. I actually developed this AO32, which is a very small, but 10 pounds in a 5-pound box type of thing. It's got big, heavy bearings and dual racks. So it's really tiny. But your customer was doing some kind of spraying booth of some sort, and you need to have a pretty rugged shaft, because the spray nozzle would produce a reaction force, and he had to have the actuator outside of the spray booth. So we came up with our little AO32, but we put some big honking bearings on the outside to support 1/2-inch diameter shaft instead of our normal 3/8. And it's got a long shaft with a long keyway, so they can adjust the position of their spray nozzle. I think it was actually vertical at the time, but I don't remember precisely. But so, with a few extra parts, we made these bearing adapters and put in some bigger bearings. Actually, they're off-the-shelf bearings for us for another actuator, and then a special shaft. And there we have it. I think they made quite a few of these over the years, but then moved on to something else. I don't know what.
The fact that you still have one and have access to it, I think that's pretty cool too. That also shows backwards compatibility and long-term support. So that's a pretty cool testimony there.
Actually, I want to stop you there, because that is an important part. We've been making these products since 1967, and some of them have become obsolete. We don't make them anymore, but almost any of our parts will fit directly, or all of our parts will fit directly into the same place that the one that they bought 30 years ago. And we get calls, not unusual. I've got this actuator, it's been running 30 years and it's starting to slow down. Can you sell me a new one? I said, sure, we'll sell you a new one, or we'll rebuild the one you got. Either way, they're very durable and they're always backward compatible.
That is good. Cool. The next application was one that you and I developed, Norman. And this was an application that the actuator laid on its back and was rod up, and the rod was extended long, and on the end of the rod was a disc, kind of like a frisbee or a plate. And in that plate, there was a series of holes around the perimeter. And I don't have a good picture of that end application, but if you kind of think of a clock and every place where the number would be, there was a round hole. So this is laying on its back, shaft up, and this plate is actually a ceramic disc, and it's inside of a high temperature oven. And so our actuator is outside of the oven, but our workpiece is inside the oven. And as this indexed around step by step, what we were doing is we were presenting a small crucible, and we're setting it underneath the dispensing head. We would dispense into the crucible, and then we would advance. The next one would dispense, but alongside where we had just dispensed into, a cylinder came up from the bottom with a load cell on it, and we would measure the weight of what was dispensed to make sure that we had an accurate dispensing. And this was the thing that had to index the right amount. But I came to you with a challenge because the customer wanted 20 stops around the outside of that. And what you had at that point in time was 12 stops. And this has been a continuing process, and it's a process that the customer did not want to go electric, did not want to go servo. The rest of the machine was pneumatic, and they needed this to stay pneumatic because the whole focus was on the oven and on the high temperature. And so tell us a little bit more about how we developed this and how this turned into other things.
Yeah, sure. And that was a very successful application, by the way. We still sell these things. Okay, so the indexing actuator was developed years ago, and it had a particular geometry to the teeth of the ratchet. It was just a very simple right angle cut that we would make with an end mill with the ratchet on an indexer. Well, when you get down to 30 degrees, you start cutting off the tops of the teeth. And so that was our limit, 30 degrees, 12 stops. That was the smallest index we could make. Jim says, well, my customer needs 20. So we got out our pencil and paper, redesigned the ratchet, redesigned the pawl, of course, to match. So these two drawings are just a simplified sketch of our ratchet and pawl mechanism that goes into all of our indexing actuators. So we changed the shape of the ratchet, changed the shape of the pawl, changed the shape of the cam, and we're able to get down to his 20 stops. And voila. Of course, the good thing is now there's other people that might want that thing. So we actually extended it beyond that. We went to 12.5 degrees, 15, 18, and 22 degrees. So we have made that a standard optional feature on all of our indexing actuators. And we just call them short stroke.
As you mentioned, that still is a successful application, and it's a neat application because there's zero accumulated error. When it stops the same place every single time. It can't back up, and so it always indexes. This one's fascinating, Norman. This was one of yours. Tell us a little bit more about this.
Yeah, sure. Customer came to us. This customer builds air conveyors for plastic bottles. These are things like water bottles, soda pop bottles, where they come out of a blow molder and they have to move across the plant somewhere to be filled and labeled. Very high speed, of course. These things are going by hundreds a minute. And this company had developed a special feature to their air conveyor, and that is that they put dampers every 8 feet or so in the duct, and they would have a high pressure blower that would pressurize this duct, and being able to close sections of the duct as it filled. It was actually like a buffer. So they would fill up one section, close the duct, fill up the next section, close the duct, and it would flow. You know, sometimes you'd have a lot of them closed, sometimes only one or even none, and the things are just flowing through. And that has to do with the difference in speed between the blow molding and the filling operations. So they had produced their own solution to moving the duct. And I think, yeah, this is a little hard to see, but they've got an air cylinder with a clevis mount, and then over on the right there is a crank. So the duct has a square shaft. Now, unfortunately, it looks like it's got a little cut off in this picture, but there is a, maybe go back one, please.
Mm-hmm.
Can you do
The
back one more?
original one?
Yeah, I think, yeah, I guess you can't really see. In any case, this cylinder would rotate a crank to turn the duct. The duct was on a square shaft that came poking through the side of the duct. It had a little pillow block bearing there. And so as the cylinder extended, it would run into an angle bracket because they had to be able to adjust how far it opened. And so that angle bracket had slotted holes in it. And then when the thing retracted, it also had to be adjustable. So they'd had a bracket on the other end that they could move the entire rear end of the cylinder to adjust. So, and then they had a valve on there, and I guess that's about it. So all these parts were separate. They were bolted onto the side of the duct. I actually witnessed a guy putting it together. It took him an hour and a half or so to put this thing together, and then he's got to adjust it. So he's tightening and loosening these bolts and sliding the little brackets back and forth. Very slow, time-consuming process. And the other thing that resulted from that is when that cylinder sticks out and runs into that bracket, you've got a pinch point. So in some applications where this thing was accessible to workers, they had to put this big steel cover over it, which just added more to the cost of it and made it more work to maintain. So they came to us, and we came up with this actuator. It took a couple iterations actually, but it's a all-in-one solution. And you could go to the third slide there and show a little close-up. You have one here. This thing has the valve built in. There is a little pilot valve here. It drives a spool that's built into the actuator. It has fixed orifices for the exhaust, so they don't have to adjust the speed. The other one, they had adjustable flow control valves. Somebody had to adjust it, and sometimes somebody messed around with it and screwed things up. This is all fixed in place. You can't adjust it. It has two holes. They slide onto the studs on the duct. It has a square hole in the shaft, which supports the shaft, so they don't need that bearing on the side of the duct anymore. I'm going to turn it right side up. It can go either way because sometimes they want the thing on one side of the duct and sometimes on the other side of the duct. So we had made up these labels so the operator didn't have to turn around in his mind. He can just look at the instructions on the label. Adjusting the rotation, very simple. You have this rotation adjuster with a jam nut right here. You can adjust it under pressure, see the duct go to where exactly it wants to go, and then tighten it up. Very simple. It's also sealed for washdown. They didn't do a lot of washdown, but they did occasionally, and the old system didn't stand up to that real well. So this is a very nice. Oh, they also, all you have to do is have one air hose, and this line that we had custom made with exactly the M12 connector that they wanted, lit for indication with a manual overrides for setup. The whole thing just drops right on. It takes them a few minutes to install it and then adjust it, and then it lasts. So this was a great solution to their complex assembly, and of course they bought quite a few of them. So that's that story.
Perfect. Thank you, Norman. I think we've got one more real example.
Yeah, this and I should have stepped back. This our two examples here are things where we've gone beyond the customization. So the AO32 with the long shaft, we call that customized. It's 90% standard body, racks, bearings, but seals, all that stuff. We put in an extra long shaft and the outboard bearings. So we do a lot of that customization where we change a few parts. But in these applications, these examples, we went way beyond that. We built something, designed it from the ground up to solve a very specific problem. So here's the next one. This customer is filling bottles of toilet bowl cleaner. You may be familiar with that. It's a household item. It's got this little twisted nozzle or a spout on top that allows you to put the stuff in under the toilet bowl, which is great, but it's really hard to fill. Filling equipment likes to go up and down. And so they built this big machine that would have these gripper rotators to grab the bottle, rotate it 45 degrees to present it to the filling, rotate it back, and then it goes on to another station where we do the same thing, rotate it back, they put a nozzle in it and a cap on it. So that involved a total of 16 of these special gripper rotators. So here are the tooling plates. We didn't make the hands that grab the gripper, that's up to the customer, but here are the tooling plates. You'll notice that this is a round shaft that's moving this tooling plate, one that's moving it and one that's guiding it. Well, if you look at parallel grippers, which is what the customer wanted, look at what's on the market. Parallel grippers, you can't seal them up. They've got a slot in there, there's cams or wedges that open and close the fingers. And it's just essentially impossible to seal it up. Well, this material that's in the toilet bowl cleaner is very corrosive. I mean, it's sodium hypochlorite, I think. And the only thing that will stand up to it is 316 stainless steel. So that's what we made this thing out of. I'm struggling to hold it up. So it is all 316 stainless steel. The seals are Viton. We did try to use some Calres when we had, one of the seals was not holding up real well. We tried Calres, it still didn't hold up real well. So we redesigned the geometry of the seal and solved that problem. But so here it is, 45 degrees of motion based on a completely custom rotary actuator. And this was the basic geometry is our compact A752 rotary actuator. But of course, every part about it otherwise is completely custom. So anyway, there's an example of an actuator that we designed and built from the ground up for this one particular customer. And it wasn't a huge quantity. I think we sold, well, there was 16 of them on the machine. They only built one machine. We've sold them a few spares just to have. But so even if it's not thousands of parts, we are willing and able to do that.
Awesome. Thank you, Norman. Well, I think that kind of gets us to the end of our examples, to our Q&A. So if you guys have any questions, again, drop them in the chat. And I'm going to start off with this one here. Are there any specific red flags that suggest the standard actuator won't meet an application's need, requiring a custom solution?
I'm not sure there would be a red flag, but what we look for is opportunities. You know, if the actuator just, well, for example, the material, that would be a red flag. In this case, with the with the toilet bowl cleaner, none of our actuators are going to stand up there because our actuators are made of aluminum. So that immediately means it's a special from the ground up. We have done other 316 materials before. So that would be considered a red flag. But more often it has to do with, do we have an opportunity to create something that will really optimize their production, their machine, like the one with the duct? Because yeah, we have rotary actuators, but none of them have all these features that are completely suited to their particular application. So it's a mix, maybe some red flags and maybe just opportunities.
Okay.
In our collaboration going through stuff, you've always mentioned to me, how are we going to stop it? Are we stopping on an external hard stop? Are we stopping on the rack? And how fast are we going? And what's our moment of inertia? How much weight are we trying to slow down? And every time you're asking me that question, you're diving into gear strength. And how many times are we going to repeatedly hit the same gear in the same place? And how long is that for fatigue and lasting? And different times you've steered me into one size larger actuator. Sometimes we've steered into an external shock, an external hard stop, something that has allowed us to either go faster or to last longer, because your comment to me has always been, we can get it moving. It's how are we going to stop it? And so that's always been the question that's stuck in the back of my mind is, how are we going to stop the load?
Absolutely. That is the crux of the matter. These things have a lot of torque. They can accelerate a load very quickly. But then, you got to stop it. So we do have various options for absorbing that kinetic energy, cushions, bumpers, occasionally some internal shock absorbers. But shocks don't fit real well into a rotary actuator. And that's because the pistons are actually moving very slowly, because they're only a little way away from the center of rotation. Your load may be out a foot away, so it's traveling at a much higher velocity. So if you can stop the actuator out there where you got a high velocity, shocks are much more comfortable with a high speed, long stroke stop instead of a very short, hard stop. So, and external stops, even without the shocks, are always a good thing. We are actually developing a new actuator that'll be coming out soon that has a real advanced bumper that will actually move. A lot of bumpers like ours, most of ours, are just a rubber pad. The amount of deflection that occurs during this stop is only a few thousandths of an inch. We have got something that's actually going to act over about 5 degrees. So it becomes a real energy absorbing feature. And at the same time, it'll also have a regular pneumatic cushion, and the rotation adjuster in this new one that's coming out the cushion moves with the rotation adjuster. Normally, if you adjust the rotation, you're shortening up the amount of cushion stroke that you have. So we're looking forward to getting that product out on the market.
Nice.
Very cool to hear. You guys, we do have one more question. What is a standard lead time on a custom actuator?
Well, standard lead time and custom are two different things. Our standard lead time varies with our backlog. Right now, we're a week or less. Sometimes we get out to 5 or 6 weeks, but almost always it's within a week or two. And we always leave a little bit of space in our schedule, so that if somebody calls up and says, I got to have this tomorrow or 2 days from now, we can almost always accommodate them. As far as a custom, it depends on how big the custom is. If it's like we talked before, we take a shaft blank that we have on the shelf and we just need to modify it a little bit, it probably won't affect the lead time at all, or maybe it'll add 1 day. If it's something where we've got to design this thing from the ground up, that's a different story. We're talking 6 to 8 weeks minimum, and it could be quite a bit longer. If it's something that's just not a huge amount of development work, but just basic design, then the 6 to 8 weeks is probably pretty realistic. And also depending on the materials, we have some bottlenecks and things like anodizing. If the product is all stainless steel, we don't have to do that. So I can't tell you a real definitive answer.
No, I think that was good. It's, it depends on the project. So,
yeah.
Well, if anybody else has any questions, please drop them in the chat. This is kind of the end of our webinar here. I'll give you guys another minute here if anybody has anything else they can think of to ask.
Contacting Rotomation, Norm's stuff is on the screen and my information is on the screen, and we welcome the opportunity to talk with you and talk you through the application. and see what we can do to help you get to a great solution.
Yeah, huge thank you to
Yeah,
both
I would like-
Norman and Jim. Thank you guys for sharing your expertise with everybody.
Sure. I just want to add a little to what Jim just said.
Mhm.
We've been working with Donald Engineering for a long time, and they're very responsive and knowledgeable. And I like to think the same thing about Rotomation. We're a small company. When you call our office, everybody in our office is in one room. So we've got Trish who will answer the phone. She takes your orders. She writes your quotes. She schedules the production. She does the shipping and the invoicing, and then accepts the pay. So she knows everything about your order. You're not going to go, oh, I need to talk to AP or AR or whatever. No, you got the whole shebang right there in one person. And if it's a technical question, she says, hey, Norman, get on the phone. I'm right behind her. And so is James, who sits right behind him. So all the technical information is right there. And we love digging into these specials and applications. Sometimes we like it when it's a standard item, but I love listening to the stories. Everybody's got a different way of explaining their application. Send us a picture and we'll get into it. We'll solve your problem.
Awesome. Thank you so much,
Thank you all for
Norman.
joining.
Thank you. Yeah, thank you everybody for attending. Oh, that was just a thank you. Again, thank you all for attending. We really appreciate it. If you have any questions at all, anything comes up, you can reach out to both Norman and Jim. Their contact information is on the screen. We do plan on sending a follow-up email with the presentation and the recording of the webinar, so you have it at your fingertips. But yeah, again, thank you all so much for attending, and I hope you have a great rest of your day.
Thank you.
Yep.
Thanks.